So hi everyone, welcome to another video, and today we're going to solve a new question called find k closest elements. So the question reads as given and sorted integer array, two integers k and x, return the k closest integers to x in the array. The result should also be in sorted in ascending order. um, an integer a is closer to x than an integer b if absolute value of a minus x is smaller than absolute value of b minus x. And if two absolute values are same, then we need to uh, consider the value that has lower index. So I tried to solve this using heap, mean heap, but it became too complex at one point, and I thought that is not the solution. And then I find a better solution online, and I will be going with that. So if you see that the array is sorted, so if we find the value x in the array, then it is just have to find the window with length k around, that x, where the value, the we get the absolute values as per the formula, right? But in some cases, like in example 2, the x is not present in the array. At the time we're going to get issues. Also, there will be edge cases where the x lies at the end of the array, and then we have to get issue with the pointers as well. So it gets complicated with that. But there is an easy solution to that. The first, we're going to calculate the absolute values, pre-calculate the absolute values, and then we're going to use the sliding window method to calculate what absolute value sum gives us the minimum one, and we can find it out. Let me explain that on the whiteboard. So now then, consider the example 1, where the input array is given as 1, 2, 3, 4, and 5. And our k is given as 4, and x is 3. So as I said, if we find the x in the array that is here, then we can create the pointer in left and right and keep checking our absolute value around that value, and we until we reach the k length, and we can return the value. But that will give us issue when x is not present in the array. For now, then we're going to create another array abs, and we're going to pre-calculate the absolute values. And that is, like, for I equals to 0, then 1 minus 3, that is 2, absolute value will be 2, then 1, then 0, then 1, and then 2. Okay, this will be our pre-calculated absolute value array. Now then, we're going to start our window of length k from 0th index and from k, right? 0 plus k minus 1, that is third index, 4 elements. Now we're going to calculate our running sum. Let's consider our result will be, first result will be 2, 1, 0, 1. That's absolute values. That will be translated to result as 1, 2, 3, 4. This is our initial result, and our initial sum will be sum of those absolute values, that is 2 plus 1 plus 0 plus 1, that is 4. Okay, then we're going to create a running sum. Our running sum will be like initial value will be 4. Now we're going to see our while loop. We're going to return our while loop until our jth index is less than length. And then to calculate our running sum, for example, for this window, our sum will be 4, running sum will be 4. But when we increase and go to the second window, our running sum will be running sum plus 2 and minus this 2. So plus the current index value and minus the previous beginning index value. So we're gonna calculate the running sum in this way in the sliding window, and we don't have to calculate it again with OFN operation with all the elements, right? And now if running sum is lesser than our calculated sum, then we're gonna update our sum is equal to running sum, and our result will be new slice I j plus 1, right? The new the ij that gives us the less sum, that will be our new result. For example, here we're going to get 4 here, initial sum. Second one, we're going to get 2, 1, 0, 1. Again, we're going to get 4, so we don't have to update it. For example, there is another 5 there, and we'll go here, then it will become 5, then 2, 7 plus 1, this become more, so we don't have to consider that. We're going to have our minimum sum, absolute sum result, right? And at the time we reach at the end, our result will contain the required result. So this solution is kind of kind of easy to understand and implement. So I'll be implementing this one. So let's go to our VS Code, and I have created a function and I have written the test cases as well. And now, first thing first, step 1, create your ABS array, right? That contains the ABS absolute values. So let ABS equals to array.map. Then we're gonna take our EL and we're gonna return math.abs EL minus X. So this will create our absolute array. Then we're gonna calculate our indexes. So let I and J, right, equals to 0 and k minus 1. Last index will be k minus 1, the 0 plus k, the window length, minus 1. Now then, we also gonna calculate our sum. So let sum equals to, well, we need to calculate our ABS and then slice. We're gonna find the window that is I and j plus 1, because our slice will exclude the last index. So j plus 1, then we're gonna do reduce, then take sum and element, come on, sum element, then we're gonna give it like return sum plus equals to element, and initial value is 0. So this will give us our sum, and initially our running sum will be equals to sum, and our let result also result array equals to as well the same window length array from the input array. So array dot slice I and j plus 1, because it can exclude the last index, so we have to do j plus 1. Now then, we need to write our while loop. Then we have to compare the sum and construct the result, right? So while j less than um, abs dot length. Since we already calculated the values for I equal to 0 and j equal to k minus 1, so we're gonna increment the j I by 1, and we're gonna increment the j by 1, and then we're gonna calculate our sum. So running sum equals to current running sum minus abs of I minus 1 plus abs of j. So this will give us the current sum. And then we're going to compare our sum, current sum with sum. So if running sum is lesser than sum, then our sum need to be updated with the running sum. And then we need to construct our result. The result equals to array, the original input array, then slice I, j plus 1, because it will exclude the last index. Now then, I think that's that. We just had to return the result at the end. Return the result. And this should solve our question. Let's go to the test cases. Perfect. And now let's try to run this on the Leet code. Now run the tests. So all the test cases are passing. So now let's submit it. You see, it's not the efficient one, but it is the easiest one to understand and implement. So that kind of a trade-off, it's better to implement the simple things that is simple to understand than going for complex logics that are more efficient sometimes. So hope that helps. Thank you for watching, and see you on the next video.